Yeah.
Oh.
Right.
Maybe give it a second, actually, until it shows. Okay, cool.
Cool. So welcome everyone. Just some brief housekeeping to start with. Tonight, this evening, we're going to have two sessions, the first of which will be recorded and will involve presentations from a number of highly talented individuals. And then the second session will have a Q&A, which will not be recorded. And the purpose of that is to allow a genuine discussion, including sharing things that may be challenges or difficulties, and we want to keep that quite open and transparent. And so for fairness, we decide not to record that. So again, welcome to our Carbon Clinic session 3. I'm Andrea. I'm a part of a group of very enthusiastic and committed Embodied Carbon Working Group, part of ACAN. It's myself, Aliki, Mariana, Jonathan, Devi, and we represent ACAN, which is an acronym that stands for Architects Climate Action Network UK. And as you probably know, we're a network of individuals within the architecture and the built environment sector broadly, who are keen to take action to address the climate crisis and the ecological breakdown. Our mission, as you can see, is to mobilize a movement of professionals and activists towards reaching this very important goal. And we would like to do so by building an open, supportive, and inclusive organization. So we do try to empower individuals as much as possible to seek change and facilitate efforts in a collective manner. And we have built a platform, a shared platform, mainly building on collaboration for that purpose. So next slide. We have 3 main overarching aims. The first one is decarbonize now. So we seek to radically transform the regulatory, economic, and cultural landscape in which we all operate, and the whole sector does. And we want to effectively transform the way the built environment is made, operated, and renewed to facilitate decarbonization as quickly as possible. The second goal is ecological regeneration, and we want to achieve that by enhancing and facilitating the immediate adoption of regenerative and ecological principles within architecture and the built environment, as well as society. And the third is cultural transformation. So we do advocate for a complete remodeling of our culture, working culture, and we do so by challenging the value systems, trying to redefine what really is at the core of our industry, and as well as the education system. And to do so, as mentioned earlier, we make substantial efforts to create an open and sharing network, which is what effectively brings us today. This is part of the bigger plan. So there are many, many ways in which you can be involved with ACAN, and I believe Mariana will possibly post some of these in the chat. You'll see the chat on the right-hand side of your screen. So today is part of a series of events, workshops, and seminars. Is the third session, so number 3 of a campaign we launched in the early spring called Carbon Clinics. And the idea of these Carbon Clinics is to bring together a number of industry experts who are keen to share their knowledge, their experience, as well as their challenges and difficulties in adopting and implementing the very important bit that defines much of our practice, called whole life cycle assessments in their own organizations. And the main goal of this campaign is to bring very practical, concrete insights into working practices, and in that way foster an improved dialogue between us practitioners during this process. And by doing so, we really aim to improve standards and consistency in the whole life cycle carbon assessment domain. You can find previous sessions. All of them have been recorded and published on our YouTube channel. We will post this session as well. And then on to the next slide. Some of the topics which we will discuss today, as well as the following sessions, are really discussed by us, fellow Embodied Carbon subgroup volunteers, but also drawn from some of the ACAN WhatsApp groups. And we really do believe in listening to the community. So please do suggest anything which you think would be valuable to bring forward and to discuss. And we'll definitely hear your voice and try to listen to any sort of useful advice and bring positive and useful initiatives into the community. So I think we have a poll, if I'm correct. It's just poll number 1, just before we start. And the question is, what life cycle assessment tools are you currently exploring for your own design practice? So we'll give a few seconds for you to answer that poll. Hopefully the QR code will work fine. And upon completing that, I'll pass on to Debbie, who will introduce the presenters for today's session.
Okay. So, thanks, Andrea. Today's session is called WLCA Tools, Assessment and Comparison, as Andrea mentioned. And it's a topic that comes up quite a lot in forums, webinars, and day-to-day conversations. And even in our chat today, there's quite a bit of discussion. So there are so many tools and platforms out there, so we thought it would be great and very helpful to bring them all together in a 2-part webinar. This first session is focused on the tools themselves, and we've invited representatives from different WLCL tools to give us an overview of what their tool does, how it works, where it fits in, touching on things like standards, data, and scope, and so on. And then we'll have a second session, which will be a bit more practical, where we'll invite users, mostly from architectural practices, to share how they actually use the tools in real projects, looking at more at workflows and day-to-day applications and so on. So today, presenting, we have Rahila from Preoptima, followed by Leo from WLCA, Enrique from Cerclos, Tim from FCBS, Carbon, Doug from Mesh, and Ben from Remap, or for HVEP. And each one will have 10 minutes to present the tool. And then, as Andrea mentioned, we'll have a Q&A at the end where we'll stop recording. So without further ado, I will pass on to Rahila.
Thank you, Dewi. And hello, everyone. Thank you for joining us, and it's great to be here. So I'm Rahila Khan Fitzgerald. I'm a registered architect and whole life carbon enthusiast with over 6 years experience in industry. And I'll be speaking about the early stage concept web tool from Preoptima, where I'm currently the head of business development and partnership. So Preoptima is, next slide, please. Sorry, Dre. Preoptima is a climate tech startup dedicated to developing innovative solutions to decarbonize the built environment. So our co-founders come from a background of over 25 years of academic research, and one of the first things Preoptima worked to launch was an industry-based web application called Concept. And that's what I'll be talking about today. So Concept performs real-time, accurate and easy to understand whole life carbon assessments and carbon optioneering from the earliest design stages. But as well as Concept in 2023, in collaboration with Westminster City Council, Preoptima was awarded an Innovate UK grant to develop the Planning Application Carbon Evaluation and Reduction Platform, which is quite a mouthful, so it's PACER in short. So PACER aims to support local authorities to bridge the whole life carbon skills gap and ensure carbon policies lead to real impact. In essence, Preoptima's tools cover both the industry and public sectors, aiming to make whole life carbon measurement and management more accessible and intuitive for all in the industry. Next slide, please. And why now? I'm preaching to the converted here, but I'm sure you all know that the UK has committed to an 81% reduction in emissions by 2035, of which the construction industry plays, an enormous part in. And in order to limit our global warming to less than 1.5 degrees above pre-industrial levels, as per the Paris Agreement, there's an ever-pressing need to reduce and eliminate these emissions immediately while it remains technically possible. So the longer we take to implement these policies, the quicker that opportunity window closes. And that's, I guess, why we're all here today. So next slide, please. So Concept is an early stage iterative web-based design tool based on massing modeling for quick and easy comparison of different design options. So including if there's an existing building or reuse of building elements. And why is it early stage based? So next slide, please, Derry. The ability to affect whole life carbon or the whole life carbon reduction potential of a building or built asset is highest really in those early design phases. So the ambition is to try and lock in really low carbon design decision making and principles in the early stages. And that's why the tool is based within rebirth stage 2 or pre-application or planning, pre-application planning stage. Next slide, please. The tool is based on the RICS second edition, so the most updated RICS edition, which confirms, is aligned to EN 15978. So Concept is a whole life carbon tool covering system boundaries A1 to A5, B1 to B7, C1 to C4, and Module D. It doesn't cover A0, which is pre-construction, as it's deemed negligible for this purpose, nor does it include the user carbon B8. Next slide, please. But the tool is built around UK generic databases, but users can add in further material data or databases, including EPDs if needed. And they also have access to all the pre-built building element designs, such as walls and roof build-ups. And these databases are regularly updated, so between 1 to 2 years. So in specifically A1 to A3 data has been taken from the ICE version 4 database and a couple of industry values from EPDs where there's no generic data available, for example, C30 concrete or raised access floor. And for the majority of the modules for transport, waste, in use, end of life, these follow the RICS methodology. So the tool uses expected lifespans, transport scenarios, and end of life scenarios from RICS version 2. Waste rates are primarily derived from the BRE Global Product Category rules for Type 2 EPD of construction products or smart waste, or from the same data sources, say EPDs if available. And for water use, carbon emissions for water are determined by the maximum daily water consumption values from the BRSRIA rules of thumb and the general occupancy assumptions for that building type. So next slide, please. The tool covers most of the building element categories as per RICS. So apart from prefabricated building units and category 6, which is category 6, and then works to existing buildings, which we're looking to develop upon. So each assessment breaks the whole life carbon data into the building elements, as you can see with the chart on the right-hand side, as well as by LCA module and against benchmarks. And you can download all that data as a detailed PDF report, including information about the data sources and tools methodology as well. Next slide, please. And so how does the tool actually work? It's a Concept approaches the building design holistically. So for example, any changes to the external facade will result in the tool recalculating or reassessing the structural system to align to those amended loads. For the structure, given a simplified massing model, material quantities required to calculate the carbon footprint of the structural system are estimated by automated structural design for each individual member. So individual cross-sectional sizes are calculated on imposed and permanent loading. So that's based on the use type of the building, wind pressure, and average grid sizes, which are defined by the user. So the user inputs the grid spans. The tool offers a substantial systems library, so users are able to choose from pre-built facades, glazing, internal walls, ceiling and floor finishes, external and internal door assemblies as well. And these are crucially fully editable, so the user can also create their own. And they can also create buildups relating to existing elements. So that's to support any retrofit optioneering as well. And these library buildups are highly detailed. So for example, the example you see there for the external wall includes fire stops, bolts, screws, and the breather membrane, which at times can account to a 20% increase in embodied carbon over, say, a less detailed conventional buildup. And next slide, please. But the tool in essence is very easy, intuitive, and quick to use. So it's designed for retrofit as well as common new building typologies. It's not designed for infrastructure projects or bespoke structural designs such as cantilevers, but it can be used for, say, conventional commercial buildings, offices, mixed use, or high-rise resi. It's best applied to multi-level tower or major projects and not really for one-off small-scale residential. But in order to use it, the first 3 steps are to import or create your geometry. So the tool takes a simple OBJ file, and then next the user then needs to select those design parameters. So for example, the span for the structural grid, and expressing what type of facade it is, roof or MEP systems, as well as inputting the EUI for the operational energy. Then at a click of a button, the tool analyzes the whole life carbon, and the process can be repeated again for different designs or tweaks. So next page, please. Sorry. The tool offers a comparison for those different designs, and they can be then edited and refined further. And all these options come with a detailed view of results, including a PDF report, as I mentioned, an XLS spreadsheet, so an Excel spreadsheet you can download, and also you can re-download your massing file if you've edited that at all. And in terms of support, next slide, please. The tool, any user can then access the Knowledge Hub at any point. So that's hosted online, and that sets out how to use the tool. So it's got manuals as well as information on the tool's scope and methodologies. The video tutorials as well embedded, but these can also be found on a YouTube channel as well. And in terms of cost, the tool it's adaptable to your needs. So Proxima offers bespoke licensing options.
1 minute left.
Including access to the API. And you can also go away today and try it for free with our light option. And that's for 1 project, 3 designs, 3 users. Or if you need more users and project designs, the annual licensing cost is £3,600 a year. We're also keen to have engaged users who'd like to pilot test the tool. So please do reach out if you're interested in further development of the tool or more bespoke pricing. Next slide, please. But don't just take my word for it. The tool has been avidly used. So the data you see there is similar to analyzing, say, the Shard 727 times or twice the area of Oxford. And I'm now going to say thank you. And my last slide to say, if you need any more information, do click the scan the QR code there. And I'll be handing over to Leonardo. Thank you.
Amazing. Bang on 10 minutes.
Excellent. Thank you very much for having me here. Yeah, my name is Leonardo Poli. Next slide, please. Yeah, my name is Leonardo Poli. I'm here for OneClick LCA, and I'm a consultant within OneClick LCA. And next slide, please. So OneClick LCA, at OneClick LCA, we comply with, as you can see, there are 80 plus standards. We have around 250,000 LCA datasets globally, around 20 plus integrations. We operate in more than 170 countries. Currently 200 plus employees and around 20 years in the business. Also worth noting that we are used by none of the 10 top architectural firms, 8 out of 10 top contractors, and 8 out of 10 top manufacturers. So this is a bit of an overview of the connection, or like the interconnection within the industry. Next slide, please. Our aim is ideally to power the makers of a zero carbon future. And next slide. As you can see, we are trying to do so by helping building developers to decarbonize, infrastructure developers, but also manufacturers as well as firms to do greenhouse gas accounting. We're also a member of a bunch of different organizations that you can see there, and we also operate with those collaborators that you see on the bottom of the left-hand side of the screen. The next slide. So as you can see here, what we're trying to do is to connect the entire industry, from engineers to architects to manufacturers, builders, investors, and institution, which I believe is really powerful, especially now that we're trying to decarbonize not in a silo, but we're trying to decarbonize as an industry. And as already highlighted by Rahila, we're trying to do that very, very quickly. So interconnection of individuals to maximize the return of our efforts is, in theory, is probably the best way forward. And next slide, please. So going into the technical aspects related to this, starting with the standards. So what we see here is the compliance that we have with the different standards. Starting from the top, the ISO compliance. These are the main ones that are relating to LCA. Worth mentioning the ISO 14040 series and the ISO 21927, which is all about life cycle assessment methodology, reporting and construction life cycle assessment at a global level. Looking at the ISO-EN, we obviously have to mention the EN 15978, already mentioned by Rahila as being kind of the point of reference for building LCA, but also worth mentioning that we comply with the infrastructure LCA, so EN 17472, and also obviously the product LCA EN 15804. The upside down triangle then leads to the standards, which obviously implies that the standards are also then relying on the use of the ISO EN standards. Obviously, it's an application which is specific to the manual's objective. But just to mention, we already mentioned we comply with 80+ standards. To mention a few, we see here levels. We see here BREEAM for, some that are probably well known within the building LCA space. But also we can see there SQL, PAS 2080, and maybe others that are more specifically related also to infrastructure. Next slide, please. In terms of the covered scope, because we have so many different tools, the scope that we do cover is basically the full scope that is available from A0 to C4, inclusive of B6, B7, and B8, and also module D1 and D2. You also might recognize this table from the RICS version 2. Next slide. Because we have so many tools, obviously there is a bit of need for guidance. The good news is that one-click LCA, depending on the tool that you select, the scope will be automatically preset. So here is a bit of examples of the scope preset. Some are more relevant for this audience. Just to give an example of how wide the adaptability is, we comply with levels, and the tool would automatically preset the scope to the red boundary. For RICS version 2, you could see that that's the most extensive boundary there, but also there's some more specific, like the TEC 17 or the Norwegian standard, which you can see there highlighted in yellow and what I believe is black or brown. Next slide, please. Talking of tailoring, by selecting the relevant tool, you're not just selecting the scope, you're also allowing yourself to select the right type of data and compliance for the specific tool. So when it comes to data, each different regulation, manual, standard will have its requirements. So EN 15978 or levels, we might be talking about type 3 declarations, EPDs, or type 2 declarations only. So EN 15804 aligned data, but not third-party verified, for example. That's the type of data that you will find within that tool. Also within that tool, there will be a tailoring of the results to allow you to carry out the assessment with the confidence that you will comply at every single level, whether that be the scope, the data, the reporting, and obviously the building elements that you will be inclusive. I need to specify for RICS, there's also obviously the inclusion of type 1 declaration, which would include stuff like TM65, BECD data, and also ICE. And next slide, please. So here is just a bit of an overview of the more detailed view of the data that you can find available. Obviously, this will all be tailored to the specific of the tool that you will be selecting. Let's talk about RICS. With RICS, you will have basically the availability of all the data that you see right here, talking about the major EPD providers. So all of that data will be included. Public or private EPD data, LCA data created by one-click LCA, such as constructions, or generic, which are geographically relevant for a multitude of locations. But that doesn't stop there. It also allows you to enter your specific data point, known as a private data set, to essentially model, say, a project-specific EPD, which is usually found in infrastructure lifecycle assessment, or maybe a TM65 or BECD data that has not yet been uploaded, but you may have access to because you're in conversation with that manufacturer. So then next slide, please. So here is obviously, as we already mentioned, the specific relating to the UK. We are talking about RICS version 2. We're talking about type 1 data in the specific. This data will be available within the RICS version 2 tool for carrying out of your assessment. Next slide, please. So that's basically more the technical side of the conversation, but there's also a conversation regarding when to do the life cycle assessment. And obviously, as already highlighted by Rahila, the opportunity to reduce carbon emissions is at its potential highest at the very, very early stages, maybe even before the brief has been defined, and that's at its lowest at the delivery of that project. And everything in between is essentially a reduction of our opportunity to reduce carbon. Obviously, this comes with a bit of a conundrum because it's really hard to define, even at a very qualitative level, the impacts of your sustainability-led initiatives when you don't have a design. And obviously, at that point, we have a loss of potential carbon reductions. Next slide. This is why within OneClick, we've developed a tool that will basically follow you throughout each design stage and allow you to maximize the reduction potentials and give you the tools that are relevant for you to influence, whether that be the client, whether that be the developer, whether that be the design team, or anyone else that's involved within the design process. This is all starting at the strategy level, where you can use Carbon Designer 3D, which is a generative life cycle assessment application, which allows you to generate a multitude of different designs to provide solutions. The only thing that you ideally need for Carbon Designer 3D is essentially the area of your building and the type of building that you're going to develop, and ideally the location which is going to develop. And OneClick will be able to generate multiple iterations with different structures, different arrangements. There's been a recent update where you can move from a shoebox to an E shape to an L shape, different heights. So you can see that there is different solutions that you can propose and basically supercharge the conversation even at the early stages. The other tools, the other applications that I will mention is the use or the implementation of BIM-based software. So you can obviously use Revit, you can use Bentley, you can use Tekla to import your material quantities, but you can also implement the use of Rhino, you can see there, Grasshopper, or IAS to import the modeled quantities at the even at the early stages. So there's all that additional
1 minute.
Thank you. Next slide. This is all going well in sense of executing the work, but then obviously real impacts are shown when the actions are followed through. And what's important to that is delivering a strong message. And that's exactly what we're trying to do by allowing you to find, achieve, and show reduction in the most effective and quick way. Next slide. Finally, to wrap things up, you're not alone in developing your skills in lifecycle assessment. We do have a range of tools or resources that you can use, such as the OneClick LCA Academy and the Help Center, also research and policy, and obviously the experts that are, such as myself, for example. Next slide. This is just a bit of an overview of what the Academy looks like, and it's all free for access. Next slide. And next again, because this is just an overview of the Help Center. So yeah, that's it for me. And I'm going to leave you with the QR code if you're interested in receiving a demo. Thank you very much.
Great. Thank you, Leo. My camera keeps freezing, so I'm hoping you can all still hear me.
Yes.
I think we've got Tim next.
Excellent. Hi everyone. Tim Dundecker, Feeling Like Bradley Studios. Next slide, please, Dewey. Yeah, so FCB Carbon is really the free precursor to Pre-Optimus concept and OneClick LCA's designer. So I'm going to show you what we launched 5 years ago. Next slide. I'm going to speak about, through the introduction. Our work at FCB spans master planning, education, agricultural buildings, housing, and all of this construction, we realized emitted a lot of carbon upfront and in use. And we were trying to work out, scratching our heads 5 years ago, what we do to reduce this. So next slide. We've been doing a lot of things in the meantime, apart from producing FCB carbon. We co-founded Architects Declare, we co-founded Part Z, and we're called to LETI, and we also have a route to net zero operational carbon for our buildings. And we have found that this is challenging. Next slide. So to deal with the embodied carbon side of things, we developed FCB carbon for the UK. It's an early stage design, whole life carbon calculator tool. And it's all about the direction and magnitude of carbon, and it's really a tool for comparing various design options. But it can be used anywhere in the world because it's all about direction and magnitude. And really the idea was to get FCB carbon central to early design decisions. Next slide. So in the past 4.5 years, we've had 8,500 unique downloads. You can see the spikes. It's usually around year end at universities where the students are downloading it to calculate carbon on their projects. It'd be great if we got £1,000 a year from all of these users. We'd be flush. But anyway, there it is. Now let's next slide. Talk a little bit about the technical scope. So really, next slide. To build an accurate whole life carbon model, you really need to build the materials. But at the early stage of the projects, you don't have that. You do want to know the impact of your decisions. What if I do this in this kind of structure, or if I'm going to have a different glazing ratio, etc. That's time consuming. So instead, we ask for a few inputs. And we algorithmically describe a notional building. So we build a notional building in the heart of software, a bit like you've seen in the last two presentations. And we use standard construction build-ups, and then we apply that to that notional building to produce some very fast outputs. Next slide. So just a recap, calculating embodied carbon is simple maths. You need to know how much stuff is in your building. You need to know the emissions for producing a kilo of that stuff. And it's really sort of ish like the same process as calculated operational carbon. So next slide. And here are a few free tools that calculate embodied carbon. We've got Meshwork tool, which we're going to see later, HBERT in its earlier guise, EC3 in the structural carbon tool. But all these tools are based on the actual buildings. They really are excellent, but you need to have a bill of materials. So the next slide. So alternatively, FCB carbon does that for you, calculates a notional building. And so really, it's a lot faster. If we go to the next slide, you've seen this this next slide from our previous two presenters, and really in the initial stages, if you just look at above the RRBA stages, project stages, you really do want to understand, for example, if you do a refurb or a new build, those key decisions up front, what kind of structural elements, then your facade, and as you go along, you know, it's decisions about MEP, partitions, finishes, and FF&E, which really have a much smaller impact, and you can make much further down the line. It's the next slide. It's really that carbon reduction potential reduces as we've all been saying. So if you go to the next slide, the FCB carbon is about those first 3 stages. Next slide. These are the modules. So we do cover all modules. Module D is a rough estimate. You input your operational energy manually, and it's really about calculating those pink things in that box. Next slide. And in terms of just having a look at, if you have two massing iterations within those 3 structural iterations, within those 3 facades, and a bit about floors and glazing, you get 108 design iterations. And the idea is to do that as quickly as possible. And so that's what the tool's for. If you go to the next slide, we do housing topologies. We do, within that, it's flats, maisonettes, single family house, multifamily offices, and we do new build and retrofit. Next slide. So in terms of data sources, transparency, functionality, ease of use, if you go to the next slide, the carbon factors, like most software you've seen, is from the ICE database. You really should not be using EPD prior to stage 4 because you don't know what products you're going to use until you get a contractor on board and you get into technical design. So ICE database is brilliant. We've got a database of standard construction build-ups. It's Excel-based. It's freely downloadable. It's not interoperable with BIM, and have a look at those links for training on our website. And there's a great YouTube video with Jack Williams having a fantastic detailed explanation on how to run it. Next slide. The operational energy pages require manual input. There's some benchmarks there. If you have a breakdown of energy users, that's fantastic. But if you don't, just put the headline figures in and the graphs on the right update. You do need to think about energy. It's important, and it feeds into the whole life carbon calculation and projections. Next slide. You input the embodied carbon there, the curated components. The modeling is based on previous projects and discussions with consultants and manufacturers, and we've got the list of common build-ups. The components may be different to how you would design that element. So have a look at the assumption column, and the assumptions do pop up. Next slide. Here's an example of the calculations between a sort of a building with CLT slabs and precast concrete slabs. You can see there's a biogenic carbon has a major impact, that grey bar on the bar chart. And this is what the tool's really about. We don't care that much about the absolute measurement. It's about comparison. Next slide. Here are some outputs. It's got your operational energy, and it compares it to the various standards, including the RIBA 2030 challenge. In the top right, you've got your various building components. Top and bottom left, got your whole life carbon over a different number of years, and there's some offset. There's an offset chart, tells you how many hectares of forest you need to plant. Next slide. Getting to the end now. Outputs at the top there, it's gives you an output per module and stage, and that whole life emissions chart at the bottom. The red line is assuming no decarbonization of the grid and no biogenic carbon. The blue line does assume that. You can see in this case the whole building is replaced, including its structure, because we've put in an 80-year lifespan for the structure. Obviously that wouldn't happen, but these charts are just really great to get a quick overview. Final slide, the next slide. It's just a reminder. This is what it's all about, right? We've developed this tool as just a quick and very dirty method to compare various design options. So next slide. Thank you very much. It's great hearing about all the other tools as well. Thanks, Dewey.
Great. Thank you so much, Tim. Perfect timing as well. Doing well this evening. Doug?
No pressure from me then. Hi guys, Doug, Mesh Energy. I mean, it's great to be able to follow some of these other speakers. Funnily enough, I was on the phone regularly with Jack Williams when Viv and Claire Bradley Studios were developing theirs through lockdown. I kind of got half bored and needed to understand some more about embodied carbon, and that was the genesis for creating our particular tool here. Go to the next slide, please. So just a quick overview of us. I mean, we're building services and building performance consultants. We're not architects. We're guys who are designing with wider teams. And embodied carbon, we love data at Mesh Energy as well as kind of practical solutions. But embodied carbon and actually in the wider kind of context of the work that the RIBA has been doing as part of the kind of 2030 climate challenge and all the great work that Letty's been doing. This is again what's formed the background behind our tool. So next slide if you can. And so yeah, it's built by us. In fact, the tool was actually coded by me. I mean, nobody else in the company's touched it apart from me. We've tried and tested it time and time again, used on loads and loads and loads of projects. but it's myself that coded it, and I'm pretty good in Excel, so I decided to do it in Excel. Yeah, it's like all these guys have said, this is an early stage calculator. It's not, you need to use some much more kind of professional software once you get into the real nuts and bolts of the project. We're on version 8. It's been 5 years to get to version 8, and really all we've done is just got some great feedback from the users and tweaked it and improved it and tweaked it and improved it, and that's where we're at the moment. And as I say, uses the kind of the baseline of the REBA 2030 climate challenge and the work that Letty have done together on embodied carbon, and you'll see that very obviously in the presentation of the data. If we can have the next slide. So it's been downloaded. I put there, it's been downloaded hundreds of times. Who knows how many times it's been shared, because I mean, once a practice has got it, they can share it as many times as they fancy. So this is, as was alluded to before, our calculator here is about, you need a bill of materials, or you need to know the quantities of the project, and it's as good as the information that you put into it, and the way that you put information into it is either the thickness of a board and the area of that board covers, or volume of concrete or volume of steel. So it's as Tim said, it's stuff, the volume of stuff times the embodied carbon kind of carbon factor, and so if you've got that information and you know how to use the tool, you can get the answers out very rapidly. What we have done as well is given some indicative U values. So particularly if you're doing layered, building up a wall, for example, it will give you a half decent U value because we've got those thicknesses, and we use that as a kind of a helpful guide along the way. You can pick, heat pumps and underfloor heating and radiators. Beyond the materials in the building, we've also got building services stuff in there as well. And it's a live update. As you add materials to our calculator, it live updates the impact per square meter. And I say it'll be obvious once you see the next slide, please. It shows the outputs, which again, Letty and the RIBA have done. And in fact, again, this is directly taken from work that Joe Jack Williams did. I think he did the graphics behind the one on the left there, may have done the one on the right as well. So we've got those as outputs that you can kind of print out and download once you've filled out our calculator. Next slide, please. And again, nothing particularly interesting here. It's exactly what the other guys have said. This is kind of standard stuff again in the REBA 2030 and Letty embodied carbon documentation. So we've got upfront carbon and embodied carbon. That's what you get out of the tool as you're adding materials. Next slide, please. And so as far as kind of usability and functionality goes, it's desktop. You're downloading the Excel file to the latest version, hopefully, and you can work on that on desktops and Windows and Macs and stuff. It's an Excel spreadsheet file. What we've tried to do is put all of the data for the structure in one page. It's quite difficult because even simple information, there's a lot of simple information. So there's a few tabs, but there's one main working kind of sheet for it. As I say, it's very simple data line entries. So you pick the material that you want to put into it. You say what the area is, you say what the thickness is, or you say what the volume is, and you do that for individual build-ups, be it walls, be it floors, intermediate floors, internal walls. Again, all the stuff that you can think of that goes into, or goes into that structure. And the numbers will build up and give you that instantaneous feedback. Is there anything else on that one? No, I think that's probably it. As you'll see on the right-hand side as well, I came at this from, there was a lot of interest in understanding how you could change one material and what impact that would make, or how much carbon was in a particular structure. So we've got a tree diagram on the right-hand side for a particular build-up, again, similar to what FCBS have done there. So you can see where the large chunk of carbon is in, say, a particular material being used in a wall, but also more holistically across the entire building, like how much carbon's in the floors in total, how much is in the roofs, how much is in the building services. Next slide, please. And this kind of gives you, we've got one more here. Okay, so you can pick from about 55 materials. These are materials which we've used EPD data from, but knowing that people have all kinds of weird and wacky materials that we haven't thought of, you get to put up to 30 of your own in there if you've got the EPDs or you've got the carbon information for it through the various stages. To make, even though 55 doesn't sound very much, and we've tried to condense the materials to certain types of element types, you can actually search materials. So if you know it's concrete something, by the time you've written CON in the search bar, you're down to a few materials to pick from. So we tried to make it really, really quick and easy to use that. Next slide, please, which I think kind of gives an overview of, so this is the rough kind of layout. Of course, you can't see any of the data here, but this is the kind of the interface in front of you. At the top here is the information about the project, whether it's a residential project, what some of your targets are. So you can kind of pick a LETI or an RIBA target, embodied carbon target. The yellow, the kind of the lightish yellow cells, the ones that you can kind of fill in. The blue box kind of in the middle towards the bottom is, it shows you live the carbon in those RICS life cycle stages. And again, on the far right hand side is the kind of the graphical information. So you can see the tree diagram in the bottom right hand corner for different elements. Again, there's a blue block there, which is a large amount of carbon in one of the materials in that element, and it will tell you where that carbon's coming from. And then the graph in the top right hand corner there is about carbon in the overall structural element. So one of them will be the roof, one of them will be the ground floor, one of them will be building services. So again, it kind of allows you in a single shot to be able to see the carbon impact a bit more holistically, but in enough detail that you can swap out a particular material and see instantaneously how it changes. Next slide, please. So as far as kind of ease of use and the typologies that this is typically used on, we don't kind of provide training per se. Usually we kind of upload the videos of kind of new features and generally how to use the tool, but it's so easy to use that generally we don't have too many questions. And we do have people emailing us directly, and I'll jump on a quick call with them, or one of my colleagues will. So we kind of, it tends to be a bit more kind of ad hoc like that. We haven't got a big kind of training academy or anything like that. Fundamentally, you can use this tool across any typologies. What we typically see is people using it for homes, extensions, smaller buildings. This is used a huge amount for awards entries. People call us up at the last minute and say, I've got an award entry I need to do for the RIBA, and this is a recommended tool for the RIBA to use as part of award entries. So with like 2 days to go, they're like, how can we use this tool to get us the answer that we need for this award entry? But I say it can be used for anything as long as you've got the materials and the volumes and stuff that you need. You can use it very successfully pretty much on any building that you could conceive, but it is early stage, and that's the disclaimer. And then the final slide here, just about so next slide, thanks Julie. So the final thing here is it's totally free. We give this away. We don't charge for it at all, and it has been since its inception. Of course, you know, there's a bit of us that thinks, should we be doing a kind of a pro or paid for version? And that is being considered, as we can see the immense value that people are getting out of it. And I'd also thought about possibly making an online version of this, so it's constantly up to date. You haven't got to download the particular file and making sure that you've got the latest version. And that's it. That is a very whistle-stop tour of the Mesh Embodied Carbon Calculator tool. Thank you very much.
Thank you so much. I forgot to give you a minute, but you ended on 10 minutes. Enrique, I think, is next.
Thank you. Yeah, thanks for the invitation. It's a pleasure to be here. It's great to see the new tool, the different tools, the whole growth in the industry. I think that, you know, benefiting the common goals we have, which is decarbonize now. I think that's aligned with ACAN purpose as well. So I took a bit of a different approach. So if you follow through the next slide, please. My name is Enrique Mendonça. I'm the current business development manager for Circulos. I'm an engineer with life cycle assessment background, and the focus is since 2012. So over it's been 13 years doing LCAs, whole building LCAs. That's all we do at Circles, with the main goal of decarbonizing the construction industry. Next one, please. A little bit more about my experience, because yeah, just the previous slide. Sorry, the previous slide, Dewey, please. Yeah, just because I'm sharing here my perspective with my experience with eTool, but I've also been involved in all the, comparing tools, understanding how we can increase LCA adoption in the construction industry. So I think it's all about collaborating, making sure we get a whole lifecycle assessment done on every building. I think that's the goal for everyone here. We regulate carbon. So yeah, that's the the experience I have from completing over 100 studies and training a lot of different users, different levels of expertise. So I thought of sharing a little bit of different perspective in this set of slides. Next one. First, I thought of aligning the purpose. I really liked, the purpose of ACAN. I think it's important. We need to accelerate. So that's aligned with Circles goals as well. That's what we do. We need to accelerate decarbonization now. Next one. Reduce whole life carbon buildings to zero. Of course, that's all we do at Circles. We don't do EPDs. We don't do product LCAs. All we do is whole asset LCAs from buildings, infrastructure. So that's our goal as well. Next one is we've been in the scene since 2012 with over 20 million tons of carbon savings options model in eTool. So really a technology enabler for this whole movement. Next one, please. Policies. I'm a big fan of regulated approach, because that's how we accelerate the movement. So that's also part of Circles mission. Next slide, a bit more details around improving the product, improving the technology to meet the industry advancements. So as we get more data, more research, better standards, more adoption in rating schemes or industry guidance, Circles is always keeping our products up to date to facilitate that process. And the users that are experienced with the tool, they have maintained their subscription. So with the 99% retention in the user base. Next one, please. Okay, here I put an example about this continuous improvement, the RICs. I think that's very important for the industry. We all know we need consistency in order to regulate carbon. So we have updated eTool with all the features and the functionality to meet the compliance with the second edition. Next slide. A bit more details around what was added, the new reporting modules, element categorization for both buildings and infrastructure. So it's like a single platform for all your construction projects. Default parameters, emission factors for materials, transport factors, biogenic. So dealing with biogenic separately, uncertainty. So we know the different phases and the level of accuracy. Decarbonization for future scenarios, and the standard reporting. So it's all part of the eTool functionality. Next slide, please. Allow greater use of low carbon materials. That's another mission of ACAN. It's also facilitated with the use of eTool. The next slide is a bit of detail about how you can integrate EPDs as part of your whole life carbon assessment. That's really important. As we get more EPD data, as manufacturers disclose their data, and we've seen a lot of good projects that we have that common low accuracy at the concept stage, but what we're seeing now, we're seeing like very good accuracy at concept stage, because as you get familiarized with the process, you have good example projects, good data, and sometimes you have typical construction methods, then you can start with a very high accuracy at early stages and start adopting EPDs, looking at your procurement or your supply chain very early on, and that's really cost savings as well. So we just facilitate that process, with iterations within E2 to help designers achieve that low carbon outcome. Next one, please. So putting the slides together, I was like, I don't want to be presenting a lot of features and standards, because I know, I'm the fifth presenter, and by the time I present, everyone's going to be like tired and kind of overwhelmed with figures and graphs and stuff. So I really thought about, what debugging whole LCA mean and how we can accelerate this process together. And it's really about, debugging is about removing errors, identifying and removing errors from whole lifecycle assessments. So the next slide, please. I was just kind of trying to understand from research, from experience, how we can accelerate the adoption of whole lifecycle assessments. Essentially focusing on carbon. When we say LCA, we can look at multiple indicators, but we're all here pretty much focusing on carbon. So data, I think there's a big concern in the industry about limitations around data quality, how you can compare different assessments when they're using different databases. Transparency, we really need transparent reports and optimized workflows, and invest in the user capacity. So there's a bit more detail in the next slide around each one of these items. When we integrating EPDs, or we following standard assumptions from the RICS guidance, for example, and achieve strong compliance. I think that's critical. Transparency, we've seen a lot. We've done many different studies to understand consistency issues and why results for the same building is different across different tools. Usually it comes down, I think the calculation method is the same, or the different tools will have the same calculation method, but it comes down to the input, right? The inventory information, like the billable quantities or your energy, water parameters. So that's really important to have that list of ingredients very clear displayed on your reports. In optimizing workflows is that early stage, making sure the LCA is adopted early, but also that you're integrating with the systems. We all know that doing LCAs, the majority of our time is about, harmonizing the data, making sure the data is good quality before you even start the LCA process. So integrating systems and collaborating, it's a big part of that process, as well as making sure the tools are accessible and they have really good quality support. Next one. So in terms of data and quality, it's a big topic for everyone looking to adopt whole LCAs. E2 has always been really strong on standards. That's how the tool evolved, following EN 15978 for buildings and the infrastructure standard as well, PAS 2080 compliant. So that's the main driver for E2. Regionalized LCA, database integration, and transparent modeling. Next one, please. A bit more detail about which one, but I grouped in three different, next slide, three different features and usability, as we all covered. That's a common topic for all the tools. Next one, please. E2 will have all the themes, all lifecycle modules. It can be used in all design stages for retrofit or new buildings. You have integrations. It can be used for rating schemes or regulations. So that's what the tool is used for. Next one. I think this is really a point of difference for E2 is the support and the third-party verification. So it really helps speed up the learning curve. Next slide, please. There's a bit more detail there, but I just want to finish with the next one, which is the last slide. You can just go through the whole list, because that's, I think, yeah, that's it. That's the last slide, and why users adopt whole life carbon, from creating business opportunities and reducing risks when making environmental claims, and also to achieve organization goals, net zero goals. Now we also have increased investors looking for climate-related risk analysis, regulatory requirements like GLA, increase efficiency, increase life cycle costs, reduce life cycle costs, green credits in green building rating schemes, scope 3 for the GHG protocol calculations, and product comparison. These are some of the examples of why people are using eTool. Next one, I think this is just a list of users. So you are in good company, accelerating net zero globally. And a big thank you with my contact details there for those that want to start a trial or book a demo.
Thank you so much, Enrique. And our final speaker of the day is Ben, who will be talking about HBERT, which was the baby of Rahila, who was our first speaker. So,
thanks, Debbie. Hi, everyone. It's good to be here. Yeah, I'm going to talk about HBERT. I'm Ben. I'm co-founder of a company called Remap, and we're a sort of digital transformation consultancy service. But in my previous life, I was leading digital design at Hawkins Brown, which is where I was part of the dev team for HBERT. If you jump onto the next slide. So HBERT is a tool developed by Hawkins Brown. For those who don't know Hawkins Brown, maybe they're a pretty large architectural practice. There's around 300 staff. They work across 5 studios: London, Manchester, Edinburgh, Dublin, and sort of most exotically Toronto. They work across a wide range of sectors, project scales, and that sort of really drives this approach to sustainable design that's got to really respond to a variety of clients' contexts and scales. Next slide. I'm going to talk about HBERT version 1. It goes a long way back. The development was sort of 2018, really. It's an open source tool. It developed into V2, unsurprisingly, which became an internal tool with added functionality, informed the thinking behind the latest web-based tool currently in development, which is called Vert. That's another talk entirely. I think HBERT version 1, it's a Revit plugin. It was launched in 2018. It's free to download from Hawkins Brown's website. And it's the output of a collaboration between Hawkins Brown and UCL through their engineering doctorate program. It was developed as part of a research titled Refurbish or Replace the Life Cycle Performance of Existing Buildings and Their Replacements. That was a piece of research by Dr. Yair Shorts. And that was done at the Bartlett. In short, basically, HBERT calculates the embodied carbon of modeled elements in Revit by measuring the volume of tagged materials in that 3D model and then applying carbon metrics to them. Next slide. Pretty simply, it consists of 5 key parts. There's the plugin, so the bit in your Revit toolbar. There's the material library, shown here as a sort of material list. There's the embodied carbon schedule, which is really the backbone of the tool. A simple user interface where project-specific information can be entered and where the results are displayed. And then it generates a sort of sheet within your Revit sheet list with all the graphs and graphics in it. Next slide, please. So in terms of the system boundaries, so using industry standard lifecycle stages, the tool has a cradle to grave boundary, covering the lifecycle from product and construction through use to end of life. However, it is limited by available UK data sets, and it doesn't include all in use. So B stage data, shown here grayed out, or module D. Next slide. The first and most significant is the upfront carbon. There's a large carbon load before practical completion, meaning early decisions have the greatest short-term impact, familiar phrase of the day. It's important to understand where the emissions happen over time. There's a sort of huge carbon load at this initial stage before practical completion of a building. This means the considerations we take before the building is even occupied will have the greatest effect in that short term. And the short-term effect of embodied carbon emissions. So worth noting that A4 and A5 calculations in HBERT don't yet align with the RICS V2 methodology. We skip on, please, Zoe. And then next is the in-use stage, so covering occupancy and operational emissions from energy and water. As mentioned, HBERT only covers replacement cycles, which can be significant and are important to consider early. It's not fully RICS V2 aligned. Next slide. And it's equally important whilst designing to consider the disposal of the building at the end. This may be difficult to predict in the future. However, we can design for reuse and disassembly rather than for disposal and waste. Next slide. So how do we get going? It's so easy. The first step is to sort of measure and analyze. We must sort of understand the impact of design. So getting started is super simple. Ignore that version. No, it does actually work up till Revit and including Revit 2025. But it's available from the Hawkins Brown website. You'll be directed towards a download form and you complete the information to get access to the whole package. And that includes user guidance documents, Revit template files, a case study, and then the actual sort of MSI installer. Next slide, please. Once installed, fire open Revit and the plugin will show in your toolbar. You'll need to follow the 4 steps, but most importantly, reassigning any current materials to the sort of the given HBA materials. So all the materials you need to use have the carbon metrics, and we'll come onto the material database next. To run the tool, you need to just to click the toolbar button, fill out the simple project information. That's mostly sort of GIA data, and hit publish. And it is that simple. So the tool, next slide, sorry. The tool provides 48 materials, and that's got all of the sort of metadata baked into them. They have flexible material parameters which host the carbon data, and then those feed into the embodied carbon schedules, very similar to a sort of a spreadsheet, as we've seen some of the presentations today. It's pretty crucial to tag the right materials. That's a Revit limitation, of which there are many, but one here to note is if you duplicate material, i.e. brick to brick 2, the carbon coefficients drop off. So you'll need to manually copy them from the original. That's like quite an often, that comes up as an FAQ. So those materials are based on specific databases, which we can go through shortly. Next slide. And then the output of the tool is a visual sheet. So it's some basic charts and graphics. And for those who are interested in the back end, the LCA data on the left-hand side, which is taken from the Revit schedule, the data and the schedule that underpins the tool is visualized in a sort of easy to compare graphs. The idea is to generate the embodied carbon data as early as possible in that design process within the sort of Revit environment. And material choices are being made. As we said, that's the bit sort of highest impact. And the visual element is really important. This is how designers learn and communicate with each other, and how decisions can be made and communicated to stakeholders too. Next slide, please. Common questions. Data is the hot topic. We need consistency in the data to ensure comparable analyses. We're in the process of updating the database to more recent circular ecology ICE v4 database. Many, particularly free tools, use this database as it seems appropriate. HBERT applies generic construction, end of life, and transport coefficients as a percentage that can be customized. For example, using specific EPD data. The tool also includes waste and replacement rates with more detail in the user guide, worth checking out. Also worth noting that carbon storage is not yet included. Next slide, please. And here you can see the carbon coefficients that I mentioned, and how the database information sort of corresponds to those different life cycle stages. And all these parameters are editable should you want to get into it for flexibility. Next slide. And for some users, it's also important to be able to use their own Revit templates. That might not be the case for you. However, I've put this in so that you can see that it is quite simple, with more sort of detailed instructions should you download the tool, or if you've already downloaded the tool, it's in section 5 or something, I think, of the user guide, so worth checking that out. Next slide. And then just a sort of what I've built a career on is sort of Revit limitations. Most of us use Revit in a standard way, but it does have its limitations. It's mostly based on assigning materials to a layer, which is a limitation when more than one material exists in reality in that zone or layer. So for example, a sort of standard range screen cladding will have an SFS zone with insulation. So that would include steel, insulation, air maybe. So in Revit, you can only apply one material to that layer, as you can see on the left-hand side, but in comparison to the element study illustrated on the right-hand side, although this isn't the most traditional way of using Revit, it can be useful to model each particular part of a building element to be able to assign specific materials. It's just a slight workaround, certainly worth considering. Next slide. Some other workarounds are shown here through the creation of what we call a hybrid material. So it's not an industry standard, although this does take in a deeper understanding of that sort of carbon coefficients and calculating the calculation process in the schedule. Next slide, please. However, an easy way to work is perhaps around this is to sort of try and find out the relevant EPD for the product or system you're trying to use. Range of EPDs is ever growing, as we know. There's some tips for using EPDs in HBERT. We'd recommend, in the first instance, perhaps only use A1 to A3 product stage information, converting that data into a carbon coefficient, and then create your material in Revit. And the last slide, just one more cautionary tale, is that Revit's limited. We use material takeoffs effectively to understand the bills of the quantities of materials and then generate the calculations from that. There are a few elements which are listed here that Revit won't compute the volumes of. So things like railings and mullions. It's a bit annoying, but that's the way it is. So another way to, again, work around this is to use a sort of separate schedule, work out the volumes, and then you can maybe draw placeholder masses. That's what some users have done. That represents the volume, and everything can be made a little bit more accurate that way. That's me. Thanks, Debbie.
Great. Thank you so much for that, Ben and everyone. It's great to see them all side by side to kind of get a good grasp of the breadth of the tools. Did I stop? I'll stop sharing.